By now you're probably familiar with, or at least heard me talk about, the power of ERDIC, our people, our portfolio, our premier research facilities, our product, and promote understanding. Today we're going to dig a little bit deeper. We're going to talk about the power of GSL, specifically our people, you, our products, and our premier research facilities. So come along with me, let's go for a ride and take a look.
My name is Kerry Price. I'm a research general engineer in the survivability engineering branch. I've been here for 10 years. I'm the program manager for the development of unconventional countermeasures for enhanced survivability S&T program. It's the DUCES program. Our focus is on passive protection for fixed and semi-fixed critical assets using unconventional countermeasures, things like camouflage, concealment, and decoys and deception. The work that we're doing through the DUCES program is important to the warfighter because it's changing the way that passive defense is implemented and the way that our facilities and critical assets are defended. Not limiting ourselves to just hardening as forms of passive protection, but actually looking at ways to deceive our adversaries and make advanced conventional weapons miss. I'm passionate about what I do because of the feedback that we get from our sponsors and from our customers. When we get feedback from soldiers that says the work that you're doing is making a difference, the work that you're doing is saving lives and has had a tangible impact, that's what gets us energized. Working on a team that values that and it sees the value in the work that we're doing is what gets me excited.
My name is Haley Bell. I'm a research civil engineer here at ERDIC, and I've been in the Airfields and Pavements branch for just over 14 years. For the past 10 to 12 years, maybe even 15 years, ERDIC engineers have kind of come up with a 95% solution for create a repair process for overseas in theater. And so now, once we've deployed this option and we've got it out there in the field, but now we need to scale it back. We need to look at lighter and leaner equipment. We need to look at reducing our manpower, maybe even reducing our logistics. So for this project, we went to Tyndall Air Force Base. It was a troop-supported project. We had 28 airmen that many different engineers and technicians across ERDIC came together, showcased their talents. We trained these troops in the creative repair process. This project fuels the power of ERDIC and the power of GSL mainly because of the people who were involved. The chemistry of this diverse team resulted in a highly successful product. A product that will reduce the logistical footprint of the radar process for force projection operations. And this all enhances the capabilities of our U.S. military. And I think that's the power of ERDIC.
My name is Jeff Durst. I'm a research physicist with the Mobility Systems branch, and I've been at ERDIC since July of 2009. The program I work on is called Simulation Tools for Autonomous Ground Resupply, or STAGR, and what we're doing in this project is we've partnered with TARDEC, who's the big Army vehicle lab, to work on autonomous convoy operations. So the idea is, it's a really dangerous mission. Guys are going on, you're going slow, you're predictable, so they're very prone to attack. And what the Army wants to do is actually turn those trucks into unmanned vehicles. In October of 2017, the big program, the Autonomous Ground Resupply Program, run out of TARDEC, that we have partnered with, had their first major technology demonstration. So it was an excellent opportunity for us in ERDIC, GSL Mobility to say, hey, this is what we're doing, this is why it's important, because you just saw this awesome unmanned vehicle driving around, but we played a huge role in getting that to a place where it could be fielded. There are a lot of reasons I really love working at ERDIC. One of the main ones is it is an extremely technically competent organization that does real deal research.
My name is Melissa Williams. I'm a program specialist. I've been at ERDIC for 7 years. I provide project administrative support to the engineering team in survivability. I think since just in my personality, I like helping people. At working here, I'm able to help people, even indirectly, I'm able to help people. Fueling the power of the ERDIC by supporting and helping with the planning of the execution of various projects and the innovations of these various technologies.
All right, I'm Robert Moser. I'm a research civil engineer in the ESMD research group in GSL. So the work we've been doing in support of the state of Connecticut, it really resulted from needs that they had to bring technical subject matter experts to support issues that they were having with crumbling foundations, mainly in residential homes. And so what they're really concerned about is issues with a very rare type of mineral called pyrrhotite. It's abundant locally in their region. And the issue with that is it's a highly expansive mineral, and in moist environments, it will cause the concrete to grow and rubbleize and cause structures to move, and basically these homes they're ripping themselves apart. They're good, hardworking people, and they paid their mortgages, and sometimes these houses, they're their nest egg, and they're like falling apart around them, and they have no support. They really don't know what to do. I think they were just happy to have somebody come in and give them some straightforward answers and some real-world kind of solutions with a sense of urgency to help them.
My name is Tony Lowe. I have been with the Corps of Engineers for a little over 18 years. Currently, I am a talent acquisition manager for the ERDIC. Given the complex nature of the work that we do, I understand the value of having a capable workforce. And literacy, reading, math, and science skills are the basis of being able to build a great engineer. From the STEM outreach, the things that I do outside of work, one of the things that I found is that you cannot start introducing children to STEM early enough. And so with that, I developed a program called STEM Possible, where it's actually used to implement technology-based software tools within pre-K programs, reading, math, and science skills for children who will be entering into kindergarten. I'll be honest with you, I absolutely love what I do. I love being able to impact people, to use everything that I've been given to make other people better, to push them along, to help them to achieve their goals. And when you can come to work, you can make a difference, and you can have fun in a family environment, you can't beat that. That's literally the power of ERDIC.
Let's take a look at some of GSL's products, because after all, our goal is to develop and deliver products smarter, faster, and better. So come along, let's take a look at a few examples.
Well, my name is Omar Eskelin. Everybody call me Eski. The modular protective system overhead cover is a flexible and scalable system. The system has been designed to provide protection against direct heat, basically against heavily mortars and small rockets. The system has three main characteristics. The first characteristic is a really quick system to be deployed to the warfighters. The other characteristic is that it's reusable, so you can take it with you once you finish your mission. And the third characteristic is that you don't need a special equipment to deploy the system. I think this technology is a great technology to help the soldiers accomplish their mission and at the same time stay safe in their environment. I think that's a great benefit for the warfighters, because that way they can focus on their mission, the important part of the mission. I don't have to worry about if they're protected or not.
I'm Captain Dan Harder. I'm a research civil engineer here at ERDIC. I work in the Airfields and Pavements branch, and a lot of what we do is to try to make really strong, really hard, flat surfaces. One of the projects I've been working on specifically is improving the anchorage system we've got. So these mats are held in place with these anchors you see here, these long aluminum screws, and it helps hold the mat and the road in place so that as trucks traffic over it, it's held together and you can handle uneven terrain more evenly. The original design here, you can see this high head. This is how it comes from the manufacturer, and this is designed to attach to guy wires and other products. But obviously this is damaging to tires. So we've tried a couple of different things over time to reduce the profile of that, either by cutting it down or using some 3D printed covers to get rid of the sharp edges. But eventually what we did is we reshaped the entire head and painted it down to one large hexagon. So it's a flat surface, so as vehicles travel over it, it's not a problem. Places we have to go into as the Army or as the federal government aren't necessarily accessible to most vehicles. So having roads to access areas, whether it's for logistics or supply trains or getting into different areas, accessing river routes and bridges, getting out of beaches, it's very important to strengthen that terrain so you can get these heavy vehicles over the ground quickly and safely.
I'm Mike Hammonds. I'm a Senior Scientific Technical Manager. I'm the Technical Manager for the PIER JCTD. PIER stands for Port Improvement via Exigent Repair. What we're doing is trying to assess the condition of port facilities that may have received some damage. It could be damage from a natural event such as an earthquake or tsunami, or it could be man-made damage to the pier. Assess the condition of the pier, and then develop ways to bring that pier back up to a minimum level of military utility so that it can be used for military operations rapidly within a few days after the event takes place. We just completed a couple of months ago a large operational utility assessment at Little Creek, Virginia. And we actually took a pier that was condemned, and we went out with soldiers and sailors. We took our technologies, we trained them how to use our technologies, and then we allowed them to use the technologies to upgrade the condition of the pier so that it makes their job easier. And I think that's a very, very important thing that we do. Oftentimes logistics is an overlooked part of our capabilities, but yet we have to understand that our military forces have to be supplied. They have to have fuel. They have to have weapons. They have to have their equipment. And so if we don't have a good way to get it to them, then they are going to be handicapped.
My name's Oliver Taylor. I've been at ERDIC 7 years now, and I am a research geotechnical engineer. Okay, so what we have here is the UNIT device. It stands for the Ultrasonic Near Surface Inundation Testing Device. We ran into a problem in military sensors and maneuverability, stuff like that. The portion of the ground that we interact with, which is the upper 1 meter of the ground, we couldn't actually test. We know very little about it. It took 3 iterations to get to where we are today. We ran into some pretty spectacular problems and some not so spectacular, pretty mundane problems. But at the end of the day, we came up with the design that we see here, and it's built in 2 setups. We have a static setup, which is nothing more than we add water to the pore matrix, and we let everything come to equilibrium, and we test to see what goes on there. The other case, which is what we have here, we actually create a rain event, so we have flow through this. There's not a lot that we can't do in terms of the physical equipment, because it's pretty simple and it's very modular. That was what we tried to keep it at. But the big thing with this is it's limited only by your imagination. Now, we built this thing for soil. Why? Because, well, that's what we look at. However, there's been questions up at Krell of, can we look at this for dust emissions? Can we look at this for snow and ice? So it's not just for soil. You can put anything you want in here. Where else on the planet can you come to work and do the impossible every day?
GSL has invested millions in our research facilities over the last several years, especially over this last year. It's for you to be able to produce innovative solutions to make the world safer and better. So come along with me. We're going to take a look at a few examples of what we got here in GSL. Fire in the hole. 3, 2, 1.
My name is Bill Hurd, and I'm a research civil engineer, and I have been with ERDIC for 15 years now. So this is the fragment simulation facility, and it's a fairly new facility. We've had it for about 2 years. And we have the ability to simulate fragments. It's also a ballistic lab. We shoot projectiles that vary from about 2 millimeters up to 20 millimeters in diameter. And we can shoot those from velocities that range from about 100 feet per second up to 6,000, 7,000 feet per second. So the research that we do here is in support of the Army Direct program, reimbursable work, and also a lot of times we're doing quick turnaround answers to RFIs that come in through the UROC. This actually happens quite often. A question comes into the UROC, we do a quick turnaround answer, and maybe it's a month later we'll get an email that comes in that says, we had this threat, this weapon, and you suggested that we build this to protect us from that. And last night we had an event, and this is the outcome. Everybody was safe. There's just something really satisfying about that.
My name is Jeff Averett. I'm the Chief of the Impact and Explosion Effects Branch. I've been working in GSL for about 16 years, all of which have been in the Impact and Explosion Effects Branch. The target preparation facility is about a 10,000 square foot facility that will be used for constructing targets used in weapons effects research. So the target preparation facility is an upgrade for the current facility we have. It will give us a lot more space and a lot more capability to build larger targets. It will also give us capability to load the targets onto semi-truck and trailers for shipment to other test facilities. The projectile penetration research facility is in the final stages of design and cost estimations. It should be under construction in late 2018. It's about 10,000 square feet and will cost about $6 million. It will house our current 83mm smoothbore powder gun, and it will also have space to increase our capabilities with a higher velocity gun. The experimental research done in these facilities is used by the warfighters and researchers to help improve predictive capabilities and computational models and designs of protective structures and the effects of penetrating weapons on those structures, and also the effects of those structures on the penetrators and the survivability of those weapons. As the Chief of the Impact and Explosion Effects Branch, I lead a group of some of the best researchers, best weapons effects researchers in the world. And the research that they do and the work that they do is very critical to the safety of the warfighter and our nation.
My name is Gada Alethi. I'm a senior research geotechnical engineer. I've joined the GSL team since about 4 years ago, in 2014, and before that I was working at the Seattle district for 3 years. We are here in the internal and surface erosion experiments lab. We have a couple of researchers who are conducting their experiments here. My research focus is on surface erosion, and the aim for these tests, or for the surface erosion, is we're trying to minimize or reduce the uncertainty in risk assessment when we are evaluating the consequences from breach, levees and dams. What we do in this experiment is we're compacting the soil mix, which is, we're focusing on coarse grain materials like sand and gravel. We're compacting this material in the box, and we're exposing the soil mix to different levels of flow rate. I believe that this research efforts that we are involved with are fueling the power of ERDIC and GSL, because we are contributing to the overall protection of our water resources infrastructure.
I'm Brent Town. I'm a research civil engineer in the Geotechnical and Structures Lab, Mobility Systems Branch. GSL is known as the center of expertise for mobility research within the DoD and has served that role for many decades. And our current high bay facility is the location of where all the mobility research occurred nearly 70 years ago. Our goal is to renovate and enhance the high bay facility into a world-class mobility research facility. We're also hoping to add a robotics and autonomy lab to the Mobility Research Center that would provide a modular, reconfigurable test facility for small robotic platforms and their sensors to help support R&D acquisition needs. It would also include a controlled environment for calibrating sensors, calibrating cameras, LiDAR, and other automotive sensors for use in physics-based simulations. So I enjoy being given the opportunity to work on different problems and knowing that the solutions and products that we provide ultimately help the soldiers in the field to successfully complete their missions.
My name is Stephen Judson, and I'm a research civil engineer, and I've been working with ERDIC for 4 years. So here behind me we have 2 of the 4 new Special Project Initiative test facilities, which we like to call spot cubes. They're built here at the ERDIC Test Facility Range at Fort Polk, Louisiana. Each spot cube is a large modular reaction structure, with each set of cubes being centered around a single detonation point. These test facilities can be lifted and moved using heavy-duty rollers, which allow us to adjust the standoff from 25 feet to 100 feet from the charge. So these facilities are fueling the power of ERDIC and GSL by providing us with the unique capability to validate multiple tests, articles, and wall sections with one detonation, which ultimately decreases the time it takes to conduct full-scale blast testing of multiple components and targets. I believe that civilian employees and military members rely on us to conduct this type of research in order to ensure that these systems and the buildings that they're in can protect them in the event of an attack. So as an officer in the Air Force National Guard and a civilian government employee, that means a lot to me.
Dr. Carol Johnson, research structural engineer, been with ERDIC for 19 years. The Advanced Blast Load Simulator is one of the newest additions to the Blast Load Simulator facility. So we have now 4 working devices here. 2 are conventional tubular shape with a pressure vessel on the front end, and 2 are a new combustible gas driven device used to replicate a high explosive device detonating a certain standoff or distance from our target. The newest device was added a year and a half ago at approximately $625,000. It is a prototype for the future full-scale device that will be constructed in FY19. The current prototype is a 3rd scale version of the future device that will be here in FY20, the Advanced Blast Load Simulator. Just to give you an idea about the efficiency of the device, to do the full-size shot that we can do in the blast load simulator next door would run us approximately 2 hours to 3 hours to pressurize the vessel. I can do that same test in the Advanced Blast Load Simulator in 20 minutes, which means we can get more work completed in a more efficient time and economic time than we can in the original blast load simulator. My history in this facility is I have been here since the first shovel went in the ground. We started construction in 2001, and I have been here for every shot since then. Well, I have a personal reason for being here. I had an uncle that was killed in Vietnam when his tank ran over a landmine. So this is an opportunity for me to do research in the area that might protect future soldiers that are out there.
Thank you for coming along with me today. I hope that maybe you learned something about GSL, maybe something you didn't know. I also hope that you gained a sense of pride in the things that you do. You should be proud. You're making a difference every day, discovering, developing, and delivering solutions that make this world safer and better. You are the power of ERDIC. You're the power of GSL. And for that, thank you. Way to go.